Welcome to the lectures session for diploma students. In today's lecture, we are going to analyze single phase circuits and the terminologies associated with single phase circuits. AC means alternating current, the current or voltage which alternates its direction and magnitude every time. In DC circuits, the power always remains same, that is, power is equal to the product of voltage and current. Everything remains constant in a DC circuit, whereas in AC the voltage and current vary continuously. So, taking the product V into I involves multiplying two sine waves at different angles and results in a sinusoid at twice the frequency. Now, we are going to introduce a notation called as J. It is basically called as a complex operator, which will be widely used in AC circuits. So, a complex number represents a point in a two dimensional plane located with reference to two distinct axes. The horizontal axis is called the real axis, while the vertical axis is called the imaginary axis. In the complex plane, the horizontal or real axis represents all positive numbers to the right of the imaginary axis and all negative numbers to the left of the imaginary axis. All positive imaginary numbers are represented above the real axis and all the negative imaginary numbers below the real axis. In an electrical circuit, this A plus or minus j prefix is used to designate numbers that lie on the imaginary axis in order to distinguish them from numbers lying on the real axis. The prefix is known as the J operator. So, this is the value of J, it is square root of minus 1. When you square this particular expression, you get J square, which is equal to minus 1. So, J cube is equal to J square into J. So, already we know that J square value is minus 1, that into J will yield you minus J. And one more thing is J power 4, which is equal to J square into J square, which is minus 1 into minus 1, which yields plus 1. So, wherever we find J power 4, we can replace that with plus 1. Wherever you find J cube, you can very well replace that with minus J in all the problems related to AC circuits. Similarly, in J square, you can replace it with minus 1. Similarly, J power 5 is equal to J square into J square into J, which yields a simple J. So, this is the relation between the positive real axis, positive axis, negative real axis and negative J axis. Today, we will deal with what a rectangular and polar coordinates are all about. It is nothing but rectangular and polar are two forms of complex numbers that represent the phasor quantities. A phasor quantity contains both magnitude as well as the angular position or phase. Rectangular form. A phasor quantity is represented in rectangular form by the algebraic sum of the real value A of the coordinate and J value of the B coordinate. So, expressed in the following general form. So, this is the general format of your rectangular form. C is equal to A plus JB. So, A is called as the real part and B is called the imaginary part. Next comes the polar form. The phasor quantities can also be expressed in polar form, which consists of the phasor magnitude A and the angle relative to the positive real axis, which is theta, expressed in the following general form. C is equal to A angle plus or minus theta. Rectangular to polar conversion. So, there may be every possibility that a given rectangular quantity to be converted to equivalent polar and vice versa. So, whenever you are provided with rectangular two rectangular quantities, you can multiply those rectangular quantities straight away and final final answer you can convert it to polar also, and vice versa. A phasor can be visualized as forming a right triangle in the complex plane as shown in the figure below. The horizontal side of the triangle is the real value A and the vertical side is the j value B. The hypotenuse of the triangle is the length of the phasor C, representing the magnitude, and can be expressed as follows. As we have already learnt, C is equal to A plus JB. The magnitude, it has got two quantities, one is the magnitude, the other one is the angle. So, the first magnitude we can calculate straight away by having C is equal to A square plus B square and then taking square root. Theta can be calculated by tan inverse of plus or minus B by A. The polar form gives the magnitude and angle of the phasor quantity as shown in the figure. A is equal to C cos theta. So, this can be arrived from this triangle. So, cos theta is equal to adjacent side C cos theta by hypotenuse, which is C. So, C gets cancelled. So, A is equal to C cos theta. So, this portion is C cos theta. Similarly, we can derive the value of B also. Sin theta is nothing but sin theta is equal to opposite side by hypotenuse, which is C sin theta divided by C gets cancelled. So, B is nothing but C sin theta. So, C angle plus or minus theta is equal to A plus JB. So, this is in polar form and this is in rectangular form, or in other words we can say C angle plus or minus theta is equal to C cos theta plus J C sin theta. By substituting the values of A and B over here, you can get C cos theta plus J C sin theta value. Now, let us move on to example 1. Express the following in J form: 15 angle 30. So, this is in polar form, we need to convert this to rectangular form. C is equal to 15 here, theta is equal to 30. Straight away we can apply the formula C cos theta plus J sin theta, which is nothing but 15 cos 30 plus J 15 sin 30. So, we know that cos 30 is equal to 0.86 and sin 30 is equal to 0.5. Upon substituting this, we get equivalent rectangular value as 12.9 plus J 7.5. Now, this problem is something different from the previous one. Here in the previous one we have the magnitude as 15 and the angle as 30. Here magnitude remains the same, whereas the angle is exactly the opposite, that is minus 30. So, it is negative. So, now let us see what the result could be. Here C is equal to 15 and theta is equal to minus 30. So, 15 angle minus 30 is equal to, applying the same expression, C cos theta plus J C sin theta, we have 0.86 for cos of minus 30 is cos 30, cos of minus theta is cos theta. So, cos of minus 30 is cos 30, which is 0.86, sin of minus theta is minus sin theta. So, you can see here. So, it has changed, that is the sign is changed here as negative. So, 12.9 minus J 7.5. So, here it is 12.9 plus J 7.5, and we will move on to example 3. So, 20 angle 225 degree. So, this is an obtuse angle, this 225 is an obtuse angle. Now, let us see what the result is. By applying this in the expression C cos theta plus J C sin theta, we have cos 225 is minus 0.707 and sin 225 is minus 0.707. So, we have both minus, that is the magnitude is minus and that is C part, that is real part is minus, imaginary part also minus. Then example 4, here exactly the opposite way, that is the angle is negative. So, let us substitute here, in c cos theta plus j c sin theta, we have 5 into minus 0.93, j 5 into 0.34, we have minus 4.65 plus j 1.7 in j form, that is in rectangular form. Now, we will move on to example 5. Here we need to express the rectangular coordinates, that is rectangular form which have been given to polar form. First one is 3 plus j 4. Now, we need to find out the magnitude, as we have already learnt. So, whenever you have a rectangular form like this, you need to square the real part and you need to square the imaginary part. You should make the sum and then you should take the square root, that is what has been done here. So, 3 square plus 4 square, taking square root, you have the magnitude as 5. To find out the phase angle, you need to apply this formula, tan inverse of b by a. So, tan inverse of 4 by 3 yields 53.13 degree. So, the equivalent polar form of 3 plus j 4 is 5 angle 53.13. So, whenever if you are trying to multiply any two rectangular coordinates, better you can convert each rectangular coordinates rectangular forms into equivalent polar forms and then multiply. How it is possible? You can convert that to polar form. So, you can whenever you multiply two polar quantities, you multiply the magnitude parts and then you add the angle part. So, you will get the answer in polar form. Next one is 8 minus j 6, a part is 8, b part is minus 6. So, taking square and adding and then taking square root, you get the magnitude as 10. Again we need to find out the angle, which is tan inverse of b by a, which is minus 36.86. So, the equivalent of 8 minus j 6 in polar form is 10 angle minus 36.86. Next is 8 plus j 6, we need to convert this to polar form. A is equal to, that is real part is equal to 8, imaginary part is 6, it is not j 6, it is mere 6. Then we need to find out the magnitude, 8 square plus 6 square, taking square root, we get 10. So, the magnitude remains the same. When you compare the previous problem, here 8 minus j 6 and for 8 plus j 6, the magnitude remains as 10. Whenever you take square root of this minus, it becomes a positive. So, magnitude always remains same. Now, let us see what happens to the phase angle. So, tan inverse of b by a, which is equal to 36.86, previously it will be minus, now it is plus 36.86 here. So, the equivalent of 8 plus j 6 in polar form is 10 angle 36.86, and this problem you have the real part as minus and the imaginary part as plus. Now, a is minus 6, b is 10. So, taking square root, you have 11.66, tan inverse of b by a is tan inverse of minus 10 by 6, you have negative, that is minus 59.03. So, in polar form it is expressed as 11.66 angle minus 59.03. Example 6. Now, so far whatever we have done is, we have either converted the rectangular quantity to equivalent polar or polar quantity to equivalent rectangular form. Now, what we are going to do is, now we are going to make some simple operations like additions, subtractions, multiplications and then division using the rectangular quantity as well as the polar quantity. Now, we are going to add the two vectors, a is equal to 16 plus j 12 and b is equal to minus 6 plus j 10. Suppose if the problem is given like this, if you are asked to add 2 angle 20 plus 3 angle 30, definitely you cannot add two polar quantities straight away, because it is in the form of a magnitude and angle. So, you need to convert each polar quantity to equivalent rectangular quantity, and then only you need to add the real parts and then imaginary parts respectively. But two polar quantities can be multiplied, two polar quantities can be divided. So, addition or subtraction of two polar quantities is not at all possible unless you convert those polar quantities to equivalent rectangular and then you perform the operation. Now, a plus b is equal to 16 plus j 12 plus minus 6 plus j 10. As I said earlier, addition of two rectangular quantities is quite simple. You can straight away add the real parts, 16, here it is minus 6. So, 16 minus 6 you have 10 here, and then you add the imaginary parts. So, j 12 plus j 10, so it is j 22. So, that is the result. So, it is in rectangular form. Then we need to, suppose if you want to convert this to equivalent polar, the result you should convert. How? We have already done this. So, we need to calculate the magnitude first, which is equal to square root of a square plus b square, which is nothing but 10 square plus 22 square. You have a magnitude of 24.16. Again we need to find out the phase angle, which is theta is equal to tan inverse of b by a, which is tan inverse of 22 by 10, which yields you an angle 65.55 degrees. So, in polar form, after the operation, after this addition operation, now we get a value of 24.16 angle 65.55. In the previous problem we have done an arithmetic operation like addition on two rectangular forms. Now, we are going to multiply two rectangular forms A and B. Is that possible to multiply two rectangular quantities? Yes, it is very much possible. Before that, what we have seen is we cannot add polar quantities, we cannot subtract polar quantities. Before that, that needs to be converted to equivalent rectangular form and then you should proceed with the operation, whereas the multiplication of two rectangular quantities is very much possible, and we are going to show how it is being done. So, here I am going to multiply A with B. So, 40 plus j 30 is a rectangular quantity which has to be multiplied with 4 minus j 3. In the first operation, this 40 should be multiplied with the real part, 40 into 4, and then this again 40 to be multiplied with the minus j 3. So, we are taking this minus out. So, 40 into j 3, and then this the j 30 with 4 should be multiplied. So, j into 30 into 4, then j 30 into minus j 3. So, taking this minus out, j 30 into j 3. Now, 40 into 4 is 160, 40 into j 3 is minus 120 j, 30 j into 4 plus 120 j. Now, you can see here you are going to multiply j 30 and j 3, as we have already learned that j into j is j square, the result is minus 1. So, it is a very important expression we have already learnt. So, in the previous slides we have seen that also. So, j into j will yield you j square, which is minus 1. So, that minus 1 into minus will become plus, and then 30 into 3 will be 90. So, whenever you multiply two imaginary quantities, you will get a real quantity. So, 160, this is, so this minus j 120 and plus j 120 gets cancelled. So, you have a value 250 plus j 0, there is no imaginary part here. Now, we are going to find out the ratio between two phasors A and B. So, earlier we have done problems on conversion, we have done problems on addition, we have done problems on multiplication also. Now, we are going to see what happens if to the ratio of two phasors, right. One is 100 plus j 60, the second one is 8 minus j 6. So, A by B is equal to 100 plus j 60 divided by 8 minus j 6. So, whenever you want to find out the ratio or whenever you want to divide a rectangular quantity by another rectangular quantity, you need to multiply this expression with the conjugate. What is that conjugate? What does it mean? Whenever you, what is the denominator? You see here the denominator is 8 minus j 6. Whenever you want to simplify this, you need to multiply both numerator and denominator by the conjugate of this. So, the conjugate of 8 minus j 6 is 8 plus j 6. Suppose if the conjugate is j 1, then suppose if I want to find out the conjugate of this, it is simply minus j 1, right. Is it clear? Now, I am going to multiply both numerator and denominator by the conjugate of 8 minus j 6, which is nothing but 8 plus j 6 on the numerator and 8 plus j 6 on the denominator. Now, we have already learnt the multiplication in the previous problem. So, multiplying these two rectangular quantities become much simpler here now, right now. So, 100 into 8 plus 100 into j 60 into 6, no, 100 into 8, then j into 100 into 6, 100. So, this 100 has been multiplied with j 6. So, that is the expression here, and then j 60 is multiplied with 8 here, and j 6, finally j 60 and j 6 here. Similarly, 8 into 8, 8 into j 6 minus j 6 into 8 minus j 6 into plus j 6. The result is here 800, j 600, j 480. Now, you can see j into j again, it is again minus 1. So, minus 1 into 6, it is minus 6, minus 6 into 60 is minus 360 here, it is a real number. Similarly, at the bottom, so j 6 into j 6 is j square 36, j square is minus 1, it becomes plus 36 here. So, you segregate all the real numbers, you segregate all the imaginary parts, and then you add like this. So, I have segregated all the real numbers, 800 minus 360 is 440, right. Similarly, j 600 plus j 480, you will have j 1080. Similarly, in the denominator also you segregate both real and imaginary parts, and then you perform the operation. So, this is the real part, which is 4.4, this is the imaginary part. Now, let us move on to the next example. Two phasors are given by A is equal to 5 plus j 8 and B is equal to 7 minus j 6.5. We need to perform both multiplication and division. So, A is equal to 5 plus j 8, we need to find out the magnitude 9.43. Here in this problem we are going to adopt a different strategy. In the previous problems, what we have done is we have straight away multiplied two rectangular quantities. For a change, what I am going to do right now, I am going to change this rectangular quantity to equivalent polar, and then this rectangular quantity to equivalent polar, and then I am going to perform the operation, right. So, the magnitude is 9.43 and the angle is tan inverse of B by A, it is 57.99. So, the equivalent of 5 plus j 8 is 9.43 angle 57.99. Similarly, I am going to convert this 7 minus j 6.5 also. So, 7 square plus 6.5 square, which yields 9.55. Angle, phase angle is tan inverse of B by A, which is minus 42.88. So, the equivalent polar form is what? 9.55 angle minus 42.88. Now, after obtaining the equivalent polar forms of A and B, now I am going to perform the product. How it is being done? As I said earlier, what you need to do is you need to multiply the magnitudes. So, this is the magnitude part, 9.43 is the magnitude part, 9.55 is the magnitude part. You should multiply 9.43 and 9.55. So, what is the result? It is 90.05, and then you should add this 57 and you should add this minus 42.88. So, 57.06 minus is already there. So, it is 42.88. So, it is 14.18. Then what is the ratio? Again here you have multiplied both the quantities, here you need to divide both the polar quantities. It is 9.43 angle 57.06 divided by 9.55 angle minus 42.88. For how to perform the division operation? Division can be done as such, right. So, this 9.43 divided by 9.55 can be carried out as such in the real part. For the angle, what you need to do is you need to subtract the angle, that is numerator angle minus denominator angle. Numerator angle is 57.06 minus what is the denominator angle? It is minus 42. So, minus 42.88. So, this minus 42. So, it becomes plus. So, when you add this you will get 99.94. Suppose if you want to convert the final result to equivalent rectangular quantity, it is well and good. You can very well do that by applying one of the formulae we have seen in the previous slides. Then AC voltage, it is also called as a sinusoidal voltage. AC voltage or alternating voltage changes its polarity periodically and also changes its magnitude at every instant. So, unlike the DC voltage which always remains constant throughout the time period, right from t is equal to 0 to t is equal to infinity, it always remains constant, it always remains unchanged. This AC voltage is entirely different. For every time sample it is changing. It is changing with respect to amplitude as well as the angle. You can see here. So, similarly alternating current also, an alternating current is a current which reverses its direction periodically and changes its magnitude at every instant. We have seen that. So, this is your DC, this is the time period t is equal to 0 to t is equal to infinity. So, this is the peak voltage, V is the peak voltage. It always, irrespective of time, this voltage remains constant, which is not changing. So, that is the reason why it is called as DC, that is direct current. When you look at the AC voltage in the CRO, you can see a sinusoidal signal like this. So, this is your angle 0, this is your angle 90, that is pi by 2, this is pi, this is 3 pi by 2, and finally this is your 2 pi. So, for each and every instant right from 0 to 2 pi, the amplitude is getting varied as well as the phase. Alternator, an alternating current generator is called an alternator. It works on the principle of electromagnetic induction. It is a very important phenomenon in electric engineering. So, an alternator is also called as AC generator or synchronous generator. Now, we will switch on to the working principle of alternator. An alternator works on the principle of Faraday's law of electromagnetic induction. It states that when there is a relative motion between the magnetic field and a conductor, an EMF is induced in the conductor. So, this is the magnet, north pole and south pole. Whenever you keep a conductor like this, so this is a conductor, this portion is the conductor. So, between north pole and south pole always there exists magnetic lines of flux like this. So, magnetic flux lines always exist. Whenever you keep a conductor like this, whenever you start rotating this conductor like this, whatever magnetic flux lines which originate from the north pole will not reach the south pole. Say for example, 10 flux lines are originating from north pole. So, all the 10,000 flux lines are originating from north pole, all the flux lines will not be available at the south pole because of the presence of conductor in between the field lines. Because of this, what happens? There is a change in flux. So, it is no more a flux of phi. Now, there is a change in flux here. So, because of this change in flux with respect to time, what happens? This is n, n is the number of turns of the coil. Because of this n and d phi by dt, there exists a voltage E. So, E is equal to minus n d phi by dt, we all know that. So, because of the presence of change in flux with respect to time and due to the presence of number of turns, that into d phi by dt will yield you a voltage or EMF. The magnitudes of voltage current generated depends upon the number of turns in the coil, as I said earlier, the strength of the magnetic field, the speed at which the coil of magnetic field rotates. So, we will have a quick recap of whatever we have learnt in today's lecture. We have analyzed the various single phase circuits. We have learnt the terminologies related to the single phase circuits, and we have learned something about the construction and functioning of alternator. Thank you.